sketch the inverse functions for each of these. Remember, inverse functions are a reflection in the line y equals x. So I'm going to start by drawing the line y equals x. And that means that x and y coordinates swap. So this point on the x-axis is now going to be on the y-axis, and this point on the y-axis is now going to be on the x-axis. This is going to be 6, 0. This point here is going to be 0, minus 2. So this graph is going to come up like that. The domain for the original is x is greater than minus 2. The range for the inverse is y is greater than minus 2, or equal to minus 2. The range for the original is y is greater than or equal to 0. The domain for the inverse is x is greater than or equal to 0. And reflecting in the line y equals x, this point here is now going to be here. And 2 minus 1 is now going to be at minus 1. Minus 1, minus 2, so it's going to be about here. Minus 1, minus 2. And it's going to come up something like that. So it is a reflection in the line y equals x. The domain of the original is x is greater than or equal to minus 2. The range of the inverse is y is greater than or equal to minus 2. The range of the original is y is greater than or equal to minus 1. The domain of the inverse is x is greater than or equal to negative 1. Drawing our line y equals x to sketch the inverse. 1, 0 is now going to be at 0, 1. And instead of having this vertical asymptote here, it's going to have a horizontal asymptote here coming along and bending up quite steeply like that, where that point there is 0, 1. Drawing our line y equals x, we see that 0, 10 becomes 0, 10, and 10, 0 becomes 0, 10. So this graph, when we take the inverse of it, is actually the same as the original graph. This is a self-inverse function. The inverse is equal to the original function. Here we have a relation that we're going to look at, and we want to graph the inverse of this. Unfortunately, there is no inverse of this, because it is not a one-to-one function, because it does not pass the horizontal line test. So there is no inverse. Final part of this question, we're going to sketch in the line y equals x, going through the origin. 1, 3 is going to become 3, 1. 3, 1 is going to become 1, 3. These two also swap. And again, a bit like the one here, we get the original function when we sketch the inverse, which means this is, once again, a self-inverse function.